Good morning, student. For the second lecture of Strength of Material, SOM Unit 1, Moment of Inertia. In our first slide, we will have a glimpses of what type of problem we will solve in this unit. The types of numerical: A, to determine moment of inertia about its centroidal axis, that is IXX or IYY. B, to determine moment of inertia about its perpendicular axis or polar MI, that is IZZ. IZZ is equal to IXX plus IYY. We have seen that a lamina have x and y axis. It's a plain two-dimensional lamina. So if we want to find moment of inertia perpendicular to that lamina, that means it is going to be z-axis. So this is the second type of problem which we will solve later. C, to determine moment of inertia about a point not on its centroid or centroidal axis. So these are the three different type of problem. Now in first category A, today we will try to solve that problem. Again, we will try to understand some basics. Yes, next slide. Now in this diagram, I think it's clear to you, a bit lighter. So on the top we have an irregular shaped lamina in which x-axis and y-axis are shown passing through G, which is the centroid. So here x-axis axis and y-axis becomes centroidal axis. That is, those axes which are passing through the centroid of a lamina is its centroidal axis. If you look at the diagram below, we have a rectangle having width B, depth D. Here again we have two axes, XX passing through G, that is centroid, YY passing through G centroid. So both XX and YY are centroidal axis. So in category A, we are supposed to find out the moment of inertia about axis passing through centroid. That means in question you have to find moment of inertia about XX axis or about YY axis, XX axis or YY axis. Okay, next slide. In next slide, you see some formula been given. Okay, I gave this formula so that it will be helpful for you while solving the numerical. Now just overall or in brief, I will try to explain this 2 or 3 pages of formula. We have this table, serial number, we have plane figure, then the area of the plane figure column, third column, fourth column, distance of centroid G from base. Next column, moment about centroid axis, in which we have two sub columns, IXX is equal to IG, IYY is equal to IG. Now for clarification or how to use this table, just a brief explanation. Serial number 1, we have got rectangle. You see this rectangular shape, width B, depth D. XX axis passing through G, YY axis passing through G. That is, G is the centroid. Okay, generally centroid is the most center point of that figure, most center point of that figure. So here the center point is obviously the midsection. If you look D, so half of D, D by 2. If you look to Y, half of B, B, that is B by 2 from any one end. So here they have shown D by 2 from base, D by 2 from base. So what reference they have taken? D by 2 from base. The third column area, we know area of rectangle, B into D. Next, distance of centroid. Now we have to know G, that is its distance from the centroid. Centroid यानी कोई भी base से, यहाँ पे हमने कहा है base, so from base what is its distance? So it's D by 2. Okay, Y bar is equal to D by 2. Y bar is nothing but distance from G to the base, G to the base. So Y bar is nothing D by 2. This Y bar we have already studied in the previous diagram. Now comes the formula part. IXX, that is moment about XX, moment about XX is given by BD cube by 12, is given by BD cube by 12. Okay, here you please enlarge your screen because the letters are pretty small. If you enlarge it, it will be easily visible. Okay, so BD cube by 12 is IXX, and IYY DB cube, DB cube divided by 12. Okay, so this is the way we use this formula. Okay, so in next two slide, similarly we have different plane figure: rectangular, triangle, circle, semicircle, quarter circle, and again in triangle, equilateral triangle, isosceles triangle. Okay, so all these things, different shapes are given, and formula for the area, formula from the distance of center of gravity from base, then formula for IXX and IYY. Just again we will have a look at the other two pages. Next slide. Now in this slide we have rectangle, we have a concentric circle shown, but this is basically a cutout section in between. From the center, the section is been cut out. In applied mechanics, we have we have solved numerical for such cutout section also. We were able to find out moment of area for such cutout section. Okay, so same thing, only the formula differs, only the formula for moment of inertia differs. Next we have semicircle and we have quarter circle. Okay, now here have a look at this formula. It's a semicircular section. Okay, again area pi r square by 2, y is equal to 4 r by 3 pi from base. Again you should know from where it is from the top or from base. This is important. Okay, this is important, whether it is from the base or from the top, because here the semicircle they are shown in this way. They may turn the semicircle in any other way. Okay, they may turn the semicircle in any other way. So you should know this diagram. Okay, you should be able to determine what its formula should be. Fine. In numerical, we are definitely going to solve numerical by showing semicircle by changing its position. Okay, so these are this formula: moment of inertia for IXX 0.1 r raised to 4, and moment of inertia about IYY, that is pi r raised to 4 divided by 8, pi r raised to 4 divided by 8. So whenever we try to solve the problem, I'm going to give you the formula also. I'm going to give the formula, so you don't need to worry about that. Fine. So next slide. Move to the next slide. Same again here. Next slide. We have the formula. We have the formula for the first is triangle section. Triangle section. We have the formula. B is base, H is height, area we know it, distance from center H by 3. Again same thing which we have repeated. All other things, everything is repeated. This first three column is repeated. Section, area and distance. This thing is repeated. In moment of area we had this thing. Same formula. You might have written it down or you might have taken photo about it. Okay. Only the formula for moment of inertia about centroidal axis is changing. Okay. So here Ixx is BH cube by 36. Iyy same. Iyy same. BH cube by 36. Next is isosceles or equilateral triangle. Formula is again Ixx BH cube by 36. Iyy HB cube by 48. Iyy HB cube by 48. I'm sorry. So you I'm just enlarging. Just a minute. I'm sorry, things are just not working. Now here you can see again Iyy is equal to HA cube by 12 plus HB cube by 12 for this section. Similarly, moment of inertia of triangle about its base for this section BH cube by 12. So you just need to refer to this page whenever you need to solve the problem or if you don't have the formula. Every problem which we are going to solve, I will give the formula. Okay. So moving to the next slide. Now here is the numerical. Here is the numerical. Now you see, determine moment of inertia of the following about its centroid x-axis. A simple rectangular shape is given. B base is equal to 20. Okay. And depth D is equal to 40. We have to find moment of inertia. Area is B into D, 20 into 40, 800. Ixx, moment of inertia about x-axis. Moment of inertia about x-axis. That is its resistance about x-axis. That is, its formula is given BD cube by 12. BD cube by 12. So it comes to B is 20. D is 40, so 20 into 40 cube divided by 12 and you are getting answer Ixx is equal to 10.666 into 10 raised to 4. 10.666 into 10 raised to 4. I hope it is clear. Okay, simple rectangular section. You have to find Ixx. Formula is given BD cube by 12. You just have to substitute the value. Next slide. Now here we have a different section. We have a equilateral triangle. We have an equilateral triangle. That is, all sides are equal. So B is equal to 30. B is equal to 30. Now here H is equal to 30. The formula is given B H cube by 36. BH cube by 36. Therefore, Ixx is equal to 30 into 30 raised to 3 by 36. 30 into 30 raised to 6 by 36. Therefore, Ixx, answer Ixx 22500 mm raised to 4. 22500 mm raised to 4. Okay, next slide. Here mm raised to 4 is the unit. You have to always mention the unit. You have to always mention the unit when you solve the problem. The third is determine moment of inertia about a centroidal axis for a given isosceles triangle. For a given isosceles triangle. We know, we have studied geometry. Isosceles triangle is that triangle in which two sides are equal. Here the base is 30 and the two sides are equal. That is, the other two sides, slanting sides, two slanting sides are equal. Height is given as 45. Height is given as 45. So IXX, that is moment of inertia about centroidal axis, as per the formula, is BH cube by 36. So B is 30 into H cube 45 cube divided by 36. Answer you get IXX 75937 75937.5 mm raised to 4. 75937.5 mm raised to 4. Now, next, we'll just enlarge it. I hope it's visible to you. We have to determine moment of inertia of given figure. The given figure is a circle with 20 mm diameter. Formula is IXX pi d raised to 4 divided by 64. Pi d raised to 4 divided by 64. Substitute the value. Pi into 20 raised to 4 divided by 64. So you are getting the answer IXX 7854 mm raised to 4. 7854 mm raised to 4. I hope it's easy for you. Okay. So next slide. Now here comes semicircle. Now here semicircle. I'm sorry. Just yeah. No, I think it's clear to you. Now here semicircle, it is in the same position as given in the formula, so it's easy for you to solve. Okay, but later in our next, or let's say in future, we will take some problem in which the shape of semicircle will try to change it. Okay, here very simple problem, semicircle as it is given the formula. D is equal to 190 mm. Okay, formula IXX is equal to 0.11 r raised to 4. 0.11 r raised to 4. You substitute the value. IXX is equal to 0.11 into 95 raised to 4. R is 95, so 95 raised to 4. Answer you are getting IXX is equal to 8.959 into 10 raised to 6 mm raised to 4. I hope this is clear. Okay, we'll move to the next slide. Now here is a problem. We have an equilateral triangle has base of 120 mm, base 120 mm. Calculate MI about centroidal horizontal axis. Also calculate radius of gyration about the same axis. Okay, now radius of gyration we'll see in the later. Okay, we'll just try to find out this moment of inertia about x axis. Now it has given base 120, but we also required height. The formula IXX is equal to BH cube by 36. B is given 120, we should know h. How we should find out h? So it's an equilateral triangle, all sides are equal, so all sides should be of 66, all angles, internal angle should be of 60 degree, all internal angle 60 degree. Now if we take half of the triangle, then the base b by 2 becomes 60. Half of the triangle, base b by 2 becomes 60. Okay, the height h, base 60, height h, one side of the triangle, base 60 mm, the perpendicular side of the triangle. So what we get, sine just a minute. From trigonometry, we know sine 60 is equal to opposite upon hypotenuse. H is opposite, hypotenuse 120, that is one side of equilateral triangle. So by solving, we get h is equal to 103.92. Ixx is equal to bh cube divided by 36. B 120, h 103. We substitute the value 120 into 103.92 whole cube divided by 36. Ixx, answer Ixx is equal to 3.74 into 10 raised to 6 mm raised to 4. So we get the answer. Thank you. Next slide. Now this problem, calculate moment of inertia for a given figure about its centroid. It's a semicircle, radius r is equal to 75. Ixx is equal to 0.11 r raised to 4. Ixx is equal to 0.11 in bracket 75 whole raised to 4. Answer Ixx is equal to 3.48 into 10 raised to 6 mm raised to 4. So we have substitute r is equal to 75 and we have been able to find out the answer. I hope this is clear. Next slide. Now we are determine moment of inertia about centroid x-axis for the given figure. The given figure is a quarter circle. Given figure is a quarter circle with radius r. So Ixx is equal to 0.055 r raised to 4. I repeat, 0.055 r raised to 4. Substitute the value of r is equal to 600. We get Ixx is equal to 0.055 in bracket 600 raised to 4. So Ixx is equal to 7.128 into 10 raised to 9 into 10 raised to 9 mm raised to 4 into 10 raised to 9 mm raised to 4. Next slide, please. Now these are the problem to be solved. You are supposed to solve this problem in the remaining time you have got in this lecture. Okay, and in next lecture I will tell you the answer. Okay, so what problem we have? For an equilateral triangle of side 400 mm, for an equilateral triangle for an equilateral triangle of side 400 mm. Show that moment of inertia about the horizontal and vertical centroidal axis are equal. Okay, so here you have to find Ixx and Iyy. Ixx and Iyy. The formula is already given in the table. The second problem you have to solve. A square has a side 120 mm. It's a square, so all sides are 120 mm. Calculate its MI about the vertical centroidal axis. That is moment of inertia about YY axis, that is Iyy. Please solve this numerical.